Excuse me. Okay. So now let's continue with this. So I will just give a quick revision on the sessions we started last time. So we seen like how you can use polymorphism with inheritance, right? So we have studied what is polymorphism. I told like polymorphism is a Greek word which means many forms. Okay, poly means many and morphism means forms. It means having many forms. So we have seen polymorphism can be implemented in two ways. One is called compile time polymorphism, which is also called as method overloading or early binding, because that is where the compiler decides which method to be called. As a comparison, I'll just talk about what is this method overloading, okay? So that we can discuss the differences, because in interviews you also get a question differentiate between method overloading and method overriding, okay? And it's very also important as well, because most of the time we will mix up the rules of method overloading and method overriding, which is completely different. Now let us try to understand what exactly mean by method overloading. Yeah, Naresh, you have any question as you raise hand? If you have any question, please let me know. Sometimes I was not able to see the individual chat, so was not able to answer the question. So you can directly chat in the chat window, where you can send message to me as well as to everyone. So if you have any concern, please you can post a message in the chat window. Okay. So meantime, let me tell you what is method overloading and what is compile time polymorphism, why it is called compile time polymorphism or static polymorphism or early binding. So basically in method overloading, what we have seen is, suppose we have a class here called average. We have a class called average, and inside this class average, if I make method like avg, okay, average, to find the average of numbers. Let's say I make a method for finding the average of two numbers. So I will say int a comma int b, open bracket, write the logic and close the bracket. Depends on the return value, I may return the value or I may not return any value, so I can simply say point. Okay, so this is your method for finding an average of two numbers. But the moment I define another method with the same name, the moment I define another method with the same name, but different parameters, different signature. What comes in signature? Okay, the number of parameters or the type of parameters. Let's say if I make a method with float a comma float b. If I make a method, let's say float a comma float b, then this is called method overloading. This is called method overloading. So method overloading is if you have two or more methods within a same class or in different classes also, where you have parent and child relation. If you have the method with the same name, but different parameters, whether the name of the parameters, I mean the type of the parameters are different, or the number of parameters are different. Like you can have an average method with two integers or three integers or two float, two double, then this is basically called as method overloading. So in method overloading, there is only one rule you have to remember, that it should be with the same name but different parameters. Okay, it should be with the same name and different parameters. So I can have many methods like this. I may have 10, 20 methods inside the class with the same name and different methods. I shown you the real example as well, where we uh, see that print method or print ln method, actually it is overloaded, right? You find different print methods for printing integers, printing float, printing double, printing boolean, printing short, printing long. So we have different methods for print and print ln for printing your data. So that is exactly a method overloading is. And method overloading is simple with simple rules and all. Okay. Now let us talk about what is method overriding. What is method overriding? I just shown you one of the scenario here. It could also be implemented with inheritance method overloading. Okay, and this is called compile time polymorphism or early binding, because if you call the method, okay, if you call method, let's say I call the method. So the moment I call the method, let's say I make an object of this, or I will make this method as static for now. Let's say I make this method as static, okay, so that I can call with class name, because I don't have any fields here, so it's perfectly okay to make this method as static. Now the moment I call the method, let's say average dot, okay, avg method, and if I pass the data, the compiler now sees what type of data you are passing. Based on the type of the data, compiler will decide which method to be called, okay, at the time of compilation itself. Okay, so as I'm passing integer values, so here the integer arguments got mapped, so this first method gets called. The first method gets called because I'm passing an integer value. Compiler understands, okay, you're passing an integer value, so the integer method has to be called here. So this is how the method binding happens at early. So that is why it's called early binding, or it happens at compile time. So it's called compile time polymorphism or static polymorphism. So here compiler decide which methods to be called. And if you're making any mistake with calling the method or passing the wrong arguments, the compiler complains you that you're calling a wrong method. Let's say, for example, if I called average dot avg 2.5 comma 3.5. Now tell me which method gets called now, the first method or the second method? Which method gets called here? The first method or the second method? Okay, so everyone thinks the second method gets called. Okay, but let me tell you, it will give a compile time error. Okay, so there is no match for this actually. There is no match for the first one. There is no match for the second one. Why? Because in Java, okay, anytime you call any uh, values with decimal point will be treated as a double. Okay, will be treated as a double. This is how basically confuses you, because it looks straightforward and you directly thinks that as I'm passing decimal value, so float will be passed, but you will be getting an error, right? We tried this, we seen this when we learn method overloading. Now I hope you can recall that these values are double, so there is no method for double. But can it be mapped, can we narrow it and map with float? No, because narrowing cannot happen automatically, so double values cannot be converted to float, so you will be getting an error. You can try and you can tell me that this will give you an error because double values cannot be mapped with the float values. So how to fix this? How to fix so that the float arguments gets called? I am already writing 2.5 here, so I wanted to call the methods with a floating point value. Very nice. So I have to suffix with f, right? I have to suffix with f, telling that it's a floating point value. Now it gets mapped. So you all understood why earlier it was giving an error when I try to pass these decimal values, because there is no exact match, right? There is no exact match. And moving forward in method overloading, we have seen like first compiler always look for the exact match. If there is no exact match, then compiler will look for widening, or then it will go for wrapper classes, or it can look for variable length argument. So we have seen how things evolved from Java 1 to Java 2 from to Java 5 in method overloading concept. Okay. So with this, let us talk about what is method overriding. Let us talk about what is method overriding. Okay, so first thing we have seen method overriding. If we already have a class, if we have a class called parent, okay, if we have a class called parent, and inside this class, we have a method. Okay, let's say we have a method called car. okay, as we have seen in our last example. And I will be having a car here called Nano. Okay, I will be having a car here called Nano, and then this class ends. This class ends here now. Okay, now, if I go here, if I go to child class, let's say we have a class called child, which extends from the parents, okay, which extends from the parent class. Now inside this parent child class, okay, it's not because this car method is directly available to me. So with child class object, I can call the car method and I will be getting Nano. But being a child class, I have a right that if I don't like the implementation of the parent class method, if I don't like the implementation of the parent class method, I have an option that I can rewrite this method. I can rewrite this method, okay, with same name and same signature, same parameters. There are other rules we will be talking about today, but the first rule of method overriding is it should be in inheritance. You cannot override a method inside the same class. That will not be allowed because that basically treated as method overloading. And in method overloading, you cannot have a method with same parameter. Whereas in method overriding, it should be same parameters. Okay. But what if I change this with one parameter, guys? Will it be allowed? Suppose in parent class, I have a method called car with no arguments. And in my child class, if I have a method with car with one argument, will it be allowed? Okay. Navya thinks it is not allowed. Let us check with others as well. What do you think, guys? What do you think? That will this be allowed if I have a method called car with no arguments, and if I define a method inside the child class with one argument? Okay, Sarika thinks yes. So how it is possible, Sarika? Is it a method overriding? Because we have just learned that the rule for method overriding is the name of the method should be same and the parameter should also be same. So here I'm keeping the parameters different. Yeah, same parameters. No, but it is different parameters, right? You can see here that I'm having zero parameters here, and here I'm having one parameter. So the parameters are different. So what do you think now? Is it allowed as a method overriding? Okay. Meantime, let me check with everyone here. Yeah, requesting like everyone, like those who join with rule number, please can possibly join with your name. Okay. So that we can interact with you. And I would like to check with others here. Like, what do you think, Anirudh, Shruti, Manoj, Renee, Vishnu? What do you think? Is it allowed? Will it be allowed to have a method with same name but different parameters in two different classes? Tarika, I hope your confusion gets clear that it's not same parameter, it is different parameter. So would you like to reconsider your answer? You said yes, it is allowed, but now you can see it is same name but different parameters. Same name with different parameters. Okay, now let me conclude. Actually, this is allowed, and this is called method overloading, not method overriding. As I told you, method overloading can also be possible in different classes, like parent and child class. So remember, it will not give you any error. Okay, it will not consider as method overriding because the rule for method overriding is the name of the method should be same as well as the parameter should be same. The name of the method should be same as well as the parameters should be same. But if I give a different parameter, if I give a different name itself, then it will be a different method. But if I give the name same, but different parameters, then it will be treated as method overloading. Because in method overloading, what is the rule? Name of the method should be same, but parameters should be different. So the moment you make a parameter as different, then it will become a different method. I mean, it becomes an overloaded method, not as overriding. So it is. Navya, is this clear for you now? That it is allowed and it is called method overloading, not method overriding. Everyone, can we have a quick response on this that you all understood? Yeah, thank you, Navya. Can we have a quick response from everyone that you all understood what is method overloading and what is method overriding? Yeah, thank you, Sangeeta. Thank you, Sarika. I know it's morning time, but thank you, Ajay. Thank you, Akila. Thank you, Shruti. Great. Okay. So it will be allowed. But uh, I wanted to perform method overriding, right? So the rule for method overriding, the basic rule for method overriding is the name should be same and parameter should also be same. Implementation can be different. Now, child can have BMW. Okay, child can have BMW. Okay, now if I make an object of parent class, if I make an object of parent class and call the, let me also write the return type, otherwise it will not be act like a method and it will give an error. But now let's say, for example, if I make the object of the parent class, how? Parent P is equal to new parent, and call P dot car. Tell me which method gets called now? Which method gets called? If I say parent P is equal to new parent P dot car. So the parent method gets called or the child method gets called? Parent method gets called, right? Because I'm making an object of the parent class and I call the car method. So parent class car method will get called, okay? Because it is the original method present in the parent class. But if I make an object of the child class, if I make the object of the child class, let's say child C is equal to new child, child C is equal to new child, and we say dot C dot car method, which method gets called now? The child method or the parent method? Because I'm making the object for the child class, which method gets called now? Child method or the parent method? Okay. Navya says it will call the child method. Do you all agree with Navya? Yeah, Shravani also says it will call the child method. That's nice. Great. So it will call the child method, right? It will call the child. Okay. Now, I have a few questions to ask. So we can actually conclude the fundamentals of method overriding, and then we will go to the depth of the method overriding, then continue with why it's called late binding or runtime polymorphism, what happens at dynamic method dispatch, and how you can perform upcasting and downcasting. A lot of interview topics we will be discussing today. So with that, let's proceed and see what is there in our slide. Okay. So I hope this concept is very clear for all of you. And one more thing, like we also did one small exercise to make you understand what is method overriding. Let me just quickly tell you. Now, let's say, for example, we created a class called addition, and we created a few fields like A, B, and C for storing A value, B value, and C value. We created a constructor for initializing the values, okay? And then we perform addition and then return the result. So this is simple and basic addition program. Okay, this is simple and basic addition program. Then what we seen last time, if I make an object of addition, if I make the object of addition like this, addition x is equal to new addition. And if I simply print system dot out dot print ln, and if I print the object, actually I told you whenever I print the object, there were two important interview questions we covered, that whenever we print an object, whenever we print the object, what happens? The toString method of the object class gets called. Okay, the toString method of the object class gets called, and what it prints the name of the class followed by the hash code. Okay, the name of the class followed by the hash code. That is a default behavior of the toString method. That's a default behavior of the toString. Now, as we know, like object class is a universal parent class. So your addition class is a child class of parent class. Like in our example, the child class has a feature that it can rewrite the method implementation if they don't like. If they like, it's okay, they can keep it and they can access. But if they don't like the implementation of the parent class method, they have an option that they can change the implementation of the child class. So similarly here, as it will be printing the name of the class with the hash code, I don't want that implementation. So I have an opportunity to override the method, the toString method from the object class. And the reason I also told you why I'm writing this at override, it's not compulsory, but it's a good practice to write at override, because while overriding, if I'm doing any spelling mistake or I'm not passing the parameters properly, like I'm trying to do overloading by mistake, then the compiler will complain me that, because it's decides at the runtime, as I told you. That's why it's called runtime polymorphism. So basically, compiler will not give you any error if you're doing mistake with the method overriding with name or parameters, because it will be treated as a different method or method overloading. So compiler has no issue with that. So if your intention is to override any method, make sure you write this annotation, which tells compiler to check I'm trying to override, check the rules for method override. If I'm not following properly, please complain me at the time of compilation so that I will not be getting any runtime error. Okay, so that's the reason we write this at override. We write this at override. Okay, now we try overriding this toString method. Earlier, I tried with small s, and you have seen the compiler complain me that you're not overriding properly. Then I override properly, where I have written the name, okay, with proper arguments, return type, and the access modifier, and it returns string, so I'm returning the string type. Now, as I override this toString method, so now whenever I print an object, the toString method gets called, and this result will be printed rather than the hash code getting printed. Rather than the hash code getting printed, this method gets printed. So this is one of the, the good example to understand the method overriding concept with real-time scenario. Like why we override this toString method. Will I get compile time error, Navya? If I pass the argument here, will I get the compile time error? Okay. But don't you think that it becomes method overloading? Don't you think it becomes method overloading? Yes. So would you like to reconsider your answer? Will I still get the error? Will I still get the error? No. Okay. Okay. So basically, I will get error because of this annotation actually. Okay. If I don't write this annotation, then I will not get error. Why I will get error now? Because I'm telling I'm trying to override, but I'm not overriding properly. Correct? So that's why I will get error this time. But the moment I remove this at override, I will not get any error. Okay? Because it will be act like a method overloading. Okay, it will be act like a method overloading. Now, can someone tell me what gets printed now? If line number 50, what gets printed? I can understand like some of us might not had breakfast, but you can have it while listening. That's okay. But I want you to be like answering the questions. And at least here you don't have to speak. You can just type. Nobody is watching you. So it will print the sum. Okay, Sarika thinks it will print the class name and hash code. Great. Okay, Shravani thinks it will print the sum. No. Actually, the toString method gets called, but this toString method will not get called. Why? Because this is not the toString method which actually expecting. They will be calling toString method with no argument, okay, which was there in the object class. You have not overridden actually, Shravani. You have overloaded it. So that's you need to understand the difference between method overloading and method overriding. So here I overloaded the method, not overridden the method. So this method will not get called. The original method gets called where it will be printing the default behavior, which is nothing but class name followed by the hash code, as Sarika said. Correct, Shravani and Navya? Is this clear for you? That this method will not get called and no compilation error also, because this is perfectly okay to overload the method. Okay, let's see. Now let us go here and try compiling the code. Give me a minute. Okay, let's compile the code. So here I will say Java C. Okay, I hope name is test.java. It gets addition cannot be applied to the given type. Okay, because I'm passing the arguments, I'm calling the wrong constructor. So that's why I was getting an error. Okay, let me make it 2,3 because it has a constructor with two parameters. I'm trying to call no argument constructor. Now I compile the code gets compiled. You see there is no error. When I run the code, you can see here that I'm getting addition followed by the hash code. The name of the addition followed by the hash code. You see, it did not give any error. It did not give any error. Why? Because it becomes method overloading, not method override. Clear for everyone? Can expect questions here because see, moving forward, our concepts are becoming little complicated, but I'll try my best to make it simple. But it will not happen only from my side. Your questioning, your interaction is very, very important, mostly in online sessions, because I need to understand like whether it is clear for everyone. Okay. So I recommend that please ask as much as questions you can, because chat is the best way where you can put all of your questions. Even you can text me privately if you feel like it's a very simple and silly question. Please ask as number of questions you can. That will be great to proceed in a proper way. That is one thing. And second thing is, even if you feel like chatting is little not good for you, you can use your mic. We will allow you. Just raise your hand. We will allow you to speak. You can have your question. Okay. So can I just say, is this clear for all? Can I have some questions on this method overloading and method overriding? Very important concepts, I told you, for interviews. Having an understanding on method overloading and method overriding is very, very important. And not only for interviews, even for Viva, whatever you're learning for your academics will also be very, very important. At least, can I get the response if no questions as N? If it is clear, if no questions, can I get response from everyone here? Uh, Thank you. Oh, I got a few questions. Sorry, I was not able to see now. When will sum be printed? Okay. Uh, Anirudh, if you have to print sum, then you have to override this toString properly, then the sum will be printed. That's the first thing. Okay. Or you can also make a method for printing sum and then call that method. Instead of mostly what generally people will do is they will override toString method so that instead of calling separate method, you can print the object and your required result can be printed. So the moment I will override properly Anirudh, then the sum will be printed now. Now this overridden method gets called. Okay. Now the overridden method gets called. Earlier it was not printing because I was not overriding properly, it becoming overloading. Now you see sum is getting printed, but it's giving 0. Let me see why it's giving 0. A and B getting added, return C. Did I save the code? Yes, I saved the code 2 and 3 getting stored in A and B, adding both of this, and result is stored in C, returning the value. So it's coming to the, oh, I'm not calling the method actually. Okay. So I should say A dot add. So it's not adding, simply it's printing the default value. Now you can see that answer will be printed, sum is equal to 5. So your question got answered, Anirudh, that when it will print sum is equal to 5, okay, when you overwrite properly, okay. But if you don't overwrite properly, if you overload it, then this method is not getting called. The default method is getting called. But now one question here is, what if I write at override here? Okay, what if I write at override? Will I get compilation error now? How many of you think that it will give a compilation error? Okay, it will give error because I'm saying that I'm trying to override. The moment you write this annotation, it means you're trying to override. And are you overriding it properly? No, because the rule is the name should be same and parameter should be same. So it's not overriding properly. So yeah, we are not overriding properly. That's correct, Sangeeta. Now it will give compilation error itself. Okay, you see, method does not override or implement a method from the superclass. So it's complaining you. Earlier when I didn't use this, I did not got any error and I was getting a different answer. But the moment I write at override, I'm actually getting an error saying that you're not overriding the method properly, because I'm telling compiler that I'm trying to override the method. Please check whether I'm overriding properly or not. So it's not overriding, it's overloading. So that's why compiler is giving. Okay. So to conclude this concept and to get with the next concept, I have one small question. Please, it has been asked in big companies. So please look into it and try answering this question. So it has been asked in Google. So you see, class 1, we have a method called foo. Okay. And we have class 2 extends 1. Uh, what methods you can insert here so that your program properly compiles. The question is, what 3 methods inserted individually at line number 14 will correctly implement class 2? So what are the methods? Okay, A, option B, option C, option D. Can you tell me which methods, if I write in line number 14, my program will compile fine without any error? Take your time. I'll give you 2 minutes. Okay, take your time. 3 options you have to select. As in the question, they very clearly told you. Select 3 options. Okay, where if I add those statements, the program should still compile as method overriding. Okay, I should properly implement method overriding. Uh, which methods we can implement? Let us see as per the rule. Okay, so basically here, you know the rule for method overriding. First, I will tell you which is not applicable. Okay, so here the method is, what is the access modifier here? Anyone? What is the access modifier for this method? Because not only the return type and the method and the arguments matters, even the access modifier matters here. Okay, so here the return modifier is a default one, right? The modifier is the default modifier. Great. Okay, default modifier. Now, will option A allowed here? Will option A allowed? Let's check. Is the name of the name is same? Yes. Argument is same? Yes. Arguments are also same. Return type is same? Yes. Return type is same. But access modifier is different. Access modifier is different. What do you think, guys? Will it be allowed? As the access modifier is different, here we have default, okay, and here we have public. Is it allowed? Access modifier is different. Because the rule may be the access modifier should be same, but here the access modifier is different. So some of you thinks it is allowed and some of you thinks it is not allowed. So can you please justify, like why do you think if it is allowed and why do you think if it is not allowed? But rule is access modifier should be same. So here option number A, we have a different access modifier. Okay. Okay, thank you, Sarika. Sarika has given her suggestion, and same I'll be expecting with everyone because as I told you, like compared to method overloading, method overriding has a lot of rules, and most oftenly we will get confused with rules of method overloading and method overriding. Okay, so please let's make it very, very clear difference between them so that we can have a clear understanding and we can answer such kind of questions. Generally, get in some good companies. Okay, so some of you were telling correct that default is restricted than public. So public is weaker access modifier. So the rule for access modifier, let me tell you. Anyhow, I'm going to talk about it with examples. But the rule here is the access modifier. Access modifier, okay, can be same or it can be less restricted, but cannot be more restricted. It can be same, less restricted, but cannot be more restricted. So public is a less restricted, so this is allowed. Okay, public is a less restricted, so this is allowed. So nothing wrong with the first option because name is same, return type is same, parameters are same, and access modifier is less restricted than this default. So this is allowed. B is not allowed. Can someone tell me why B is not allowed? What is wrong with B? Method name is same, argument is same, return type is same, more restricted. Very good. Okay. Private is more restricted, so it is not allowed. Private is not allowed. Okay. Private is not allowed. Third C option, what do you think? Allowed or not allowed? Option C, allowed or not allowed? Why it is not allowed? That is the rule, Manoj. Rule for method overriding. Okay. That if you are overriding any method, access modifier can be less restricted but cannot be more restricted. Access modifiers can be less restricted but cannot be more restricted. Nice. Okay. So it is more restricted. No, let me tell you, this is where the confusion. Protected is a less restricted than default. So this is allowed. Okay. Protected is a less restricted than default. Default is more restricted than the protected. So you know the rule, right? We discussed this before. You know the rule. The rule is basically the most restricted modifier is private. Then we have default. Okay. Then we have protected. Then we have public. Okay. So this is the order. So private is more restricted, then default, then protected, and then public. Okay. See, default cannot access outside the packages, whereas protected can access outside the packages if they are child classes, right? So protected is less restricted than default. So this is allowed because protected is not more restricted, it is less restricted. Clear for all? Why option C is allowed? Okay, great. Okay. Option D, allowed or not allowed? Option D, allowed or not allowed? No. Okay. Why it is not allowed? What is wrong here? Access modifier is same default. Return type is different. Okay. Return type is different, so not allowed. Return type is different, not. Option E, is it allowed? Option E is allowed. Yes. Okay. Option E is allowed. Great. So the correct answer is option A, C, and D. Okay, option A and C. So we have seen why B and D is not correct. But anyhow, moving forward, I'm going to teach you the rules. Okay, all the rules now. So let us go and discuss all the rules. Okay, practically we will see, and we will conclude this method overriding. Okay, so that we can go to the runtime polymorphism concept. Okay, the safe polymorphism concept. Now, with this, you can see the option A, C, and E is correct for this. Okay, fine. So now what we will do is we'll go for the rules for method overriding. So one by one, we will study with practical implementation. So the rules for method overriding a method. First rule is the argument list must exactly match that of the overridden method. If they don't match, you will be ended with method overloading, which you don't want to do, but it will become method overload. So we have very clearly seen this with our example. Okay, when toString method, okay, toString method, we have seen like if I change the argument type here, or if I change the argument, it becomes method overloading. I may not be getting an error, but it becomes method overloading, so will not be allowed. It will become method overloading and will not be allowed, right? So the argument must exactly match, exactly match. Okay. So if there is no match in the argument, it is not at all a method overriding. So you will directly get an error. If you are using annotation, you will get an error. Otherwise, it will be treated as a different method or as a method overloading. But the rule for method overriding, the very first rule, the name should be same and the parameter should be same. The name should be same or the parameter should be same. Okay, instead of toString, let us do one thing. Let's try to make a different example to make you understand some of the rules. So what I will do here, let it be toString for this, no problem. I'll like take one more example to make you understand. Let's take the same example, class, and we have class A, which has a method as void m1 method. Okay, and it will be displaying system dot out dot print ln, and I'll be printing A, class A. Okay, class A. Then close the method, close the class. So this is my simple class. Now I'll be having another class as B, which is a child class of A. So I'll be saying extends B, extends A. And then I'm trying to override this method and print class B. Right? This is very straight way of method overriding. So we have a class called A, which has M1 method. Now there is a child class B. I am rewriting this M1 method with same name and same parameter is called method override. This is called method overriding. Now, if I make the object of class A, as I shown you, if I make the object of class A as A is equal to new A, and if I call M1 method A dot M1, it will call the M1 method of A. It will call the M1 method of A. Now I compile the code. The code was giving me an error because of I did not close the parenthesis for this. Okay. And then now I compile again, the code gets compiled. Now I run the code will be printing class A because I'm calling the my M1 method with class A. I'm calling the M1 method with class A. Now if I make the object of B is equal to new B and call this B dot M1. If I call the b.m1, so child class method gets called. Okay, child class method gets called. So it will print me class B. I compile the code, run the code. You can see earlier it was printing class A because I was calling with parent class method object, or I mean class A object. Now it's printing B because I'm calling child class. So I'm following the rule properly. It's called method overloading. But if I make this as int A, will I get compilation error? Will I get compilation error, guys? If I just change the argument? Okay, no compilation error. Now, what will be the answer? What will be the answer? Look at the code and tell me what will be the answer. Class A or class B? Class A. Okay, because M1 method with no argument I'm calling. So obviously this method gets called and prints class A. Even though I'm making an object of B class, child class, but class A will be printed. Okay, class A will be printed. So now compile the code gets compiled, run the code, it's printing class A. If I pass 23, which method gets called now? Okay, B method. So B method gets called. So let me compile. So compile the code, run the code now. Okay, you can see class B is getting. Now tell me, is it method overriding or method overloading? This example, whatever we implemented, is it overloading or overriding? Overloading. Very nice. Okay. So understood the difference between overloading and overriding now? Great. Okay, let's go for overriding only. Let's go with overriding only. Okay. So the name should be same and parameter should be same. Okay. In overloading, name should be same, but parameter should be different. Okay. Now the second rule is the return type must be the same or the subtype, okay, of the return type declaration. So generally, we know that return type is same, but it is also can be subtype. Okay. If I change the return type to integer, will it be method overloading or method overriding? If I change the return type to integer, and obviously I have to return an value here, otherwise I will be getting a compilation error. Let's return 10. So will it be method overloading or method overriding? Okay. So it's neither overloading nor overriding. Okay. Because if it is overloading, then parameters should be different. So same parameters you cannot overload. Okay. So just return type doesn't matter for overloading, guys. So that's why it's neither overloading nor overriding. So I will get compilation error. Clear for all? So neither it's overloading, not overriding. Why it's not overloading? Because in overloading, the rule is name should be same, parameter should be different. So here parameter is same. Okay, so it becomes overriding. And the rule for overriding is return type should be same or subtype. Return type should be same or subtype. So now I go here, compile the code. You can see I will be getting an error saying that it's not overriding properly. So M1, we cannot overwrite M1 in A. The reason is integer is not compatible with void. Integer is not compatible with void. Other error I'm getting for calling the method that I will remove anyhow, because I don't want these method to happen. Anyhow, I'll compile again. Okay, sorry. Compile again, run the, so you can see here I'm getting an error. It cannot override properly because return type is different. Clear about return type, guys? Is the return type rule clear for all? If you have a return type as something, if we change the return type, it gives you an error because return type should be same or subtype. Now my question is, can I have a return type as double and here return type as float? Will it work? Will this be okay for method overriding? Because as per the definition, you see, the return type must be same or subtype that return type declared in the original overridden method in the superclass. So it can also be a subtype, not only same, it can also be a subtype. So this is where interviewers will be test you. Okay, same is a direct thing, so everybody can answer. Okay, if it is not same, it is not overriding properly. But what is the meaning of subtype here? So if it is double and the overridden method has a float, will it be allowed for method overriding? How many of you think it will be allowed for method overriding? Okay. So everybody here thinks that it will be allowed for method overriding. How can you say, guys, that it will be allowed for method overriding? How can you say that it is allowed for method overriding? A small justification is also okay. Okay, because it's narrowing. So you mean that float can be, it's widening actually. Okay. Double to float conversion is okay. Okay. Navya thinks it's a subtype. Fine. Navya, actually, I'm just telling to everyone here as Navya raised this subtype concept. Subtype means it will happen with classes, not with primitives, guys. Okay, so whatever this definition it tells na that it should be same or subtype will be applicable to classes, not to the primitive types. Okay, so widening, I didn't say it like widening will also possible kind of thing. So it will give error. It will give error because data type is not same, neither its subtype. Okay, primitives will not have this subtype concept. So now you can see here, when I compile the code, I will be getting one error with brackets. I don't know where I missed the brackets. Okay, return type is different. So let's make it as, okay, return type was different. So I was getting error. And even here I have to give a return type. Sorry. So first fix those errors, which are very common. So then we can see the actual error. Okay. So I compile the code now. You can see here that M1B cannot override M1 in A because return type is float, is not compatible with double type. Even though double to float conversion is possible, Manoj, but it is not subtype, so it is not allowed. So this could be one confusion regarding return type. Clear for all? So does not applicable to primitive types. The subtype concept is not applicable to primitive type. Applicable to classes type actually. Class type. Let's say if it is a double class, okay, or I can go with this. Let's say if it is an object class, if it is an object and return some object or return null, okay, and this is of type string, this is of type string and return string. Now tell me, is it string is a subtype of object? I mean, string is a child class for object. Yes, so this is allowed. Understood what is mean by subtype now, everyone? This will be allowed even though the return type is different. Even though the return type is different, it is allowed because this is super type and this is subtype. String is a child class for the object class. So remember, this is mostly tested in interviews because mostly we think that the or data type, return type should be same, but it can be different. So you may get this kind of tricky questions. You see, it gets compiled, and when I run, you can see here the code runs fine and it prints class perfectly working. So here the return type is different, you see. When you get this question, if you only know that return type should be same, you will say it's wrong. You will get error, but you see it's not giving error because it should not only be same, subtype is allowed. Yeah, Sangeeta, I wanted to see your complete question. But let me wait and see here. Is the Return type is clear for all. What is the concept of return type, and it should be same and subtype. Thank you, Abhi. Let's check with others. Print stream and print. Yeah, print is a method, Sangeeta. Print stream is a class. Okay, so method and class are like not compatible. They are different, right? But if it is, let's say, for example, subscriber, if I'm returning subscriber here in our example, if I'm returning subscriber and if I'm returning WLS here, let's say, okay, can I say that WLS is a child class of subscriber, or can I say WLS is a subtype of subscriber? Yes, then it is allowed. Reverse is not allowed, huh? Reverse is not allowed. Let's say you are returning object here. Okay, you are returning the parent class is having a subtype, but child class is having a super type is not allowed. Okay, this is not allowed. Okay, let's return hello. So this is not allowed because here it has a subtype and this has a super type. So this is not allowed. So you see what compiler will tell you. Let's compile the code gets compiled, and sorry, does not get compiled, and it says that object is not compatible with string type because it's a super type, not the subtype. Sangeeta, I hope your question got clear. Okay, thank you, Sangeeta. Any other question, guys? Anirudh, you have any question on return type? I think last time you raised this question about return type and access modifier as well. So I hope it's clear for you now. Okay, thank you, Anirudh. What about other Shruti? Uh, sorry, I cannot see some of the names. Monica, thank you. Renee, is this clear? Manoj, thank you, Sarla. Akila says yes. Nice. So I hope this statement is clear for all. Okay. I hope you have also noted this in short. It will be very useful when you go for interviews and Viva questions. You can be very clear, very confident answering such questions regarding method overloading and method overriding. Okay. For JNTU, we can cover this in 5-10 minutes. You see, it took 1 hour just to discuss this couple of points because you need to understand very clear. Because if you have a clear understanding, na, you'll be confidently can go for interview, and that is only mantra. Now, regarding access modifier, I told you the access level cannot be more restricted than the overridden. Now, if the access modifier here is public, if the access modifier is public, now tell me if I make this as void again, because I don't want to focus on return type now. Now tell me for this, what modifiers are allowed? Now tell me for this, what modifiers are allowed? If the modifier, I mean access modifier is public for the parent class method, what modifiers are allowed here? Okay. Can it be default, Navya, or only public? Can it be default, protected, private? Yeah, public is a least access specifier, so it cannot be default or anything, right? I will be getting an error. I'll be getting an error. Okay. So here, if I just go back and see, compile the code. Okay. And you can see attempting to assign weaker access privilege was public. It's telling already you're having a weak access by public, but you're trying to make it default, which is not. Okay. If I make it public, it will work. What if it is default? If it is default, what access modifiers are allowed? If it is default, what access modifiers are allowed? 3 access modifiers are allowed. Public, protected, and default. Correct? Okay. If I write public, it will work. Okay. If I write public, it will work. So when I compile the code, it compiles. When I run the code, it runs and get me the output. Okay. It gets me the output. Perfect. Even if I make it as protected, that's what I wanted to show you, that protected is less restricted than default. So this will be allowed. Compile the code, it gets compiled, run the code, it's running. So that way, public, default, and protected is allowed if it is default. If it is private, what modifiers are allowed? What modifiers are allowed? If it is private, okay, all. But basically, moving forward, we will see private methods are hidden actually. Okay, because private, you know that private can access only within the same class. So it's not actually overriding. Okay, it's not overriding basically. So let's see if I put at override, what will happen? Because this is not exactly overriding. So let's see if I try to override what it will complain me. So when I just go here, compile the code, okay, it's telling me method does not override or implement from the superclass. Why? Because private methods are hidden. Okay, so you see, even if I write private here, even if I write private, okay, you see that it will again complain me the same, that it's not, you cannot override the private methods because they are hidden. Okay, because you know that private methods can only be accessed within the same class, cannot be accessed from outside, so it will be hidden. Okay, so it's not overridden actually. Forget about the rule of access modifier. The private methods cannot be overridden. Okay, so that's why I'm getting error when I'm trying to say override. But if I remove this override, then it's okay. It's not overriding method, it's a different method then. Okay, because that is hidden, so that way we are not actually overriding. Okay, you're actually not overriding, you're neither overriding not overloading, it's a different method completely. Clear with all? So this concludes our method overriding rules. I guess all these rules are clear for everyone. And you cannot override method marked as final, static, and private, all I should add. So these methods you cannot override. So this is all about method overriding. So with this, we have one more question to proceed with the next topic. Okay. In time, let me check. Okay, so we have a very less time. So actually, still we are not getting into the actual topic, but let's do how much we can cover. Let's do it quickly. So we have a question. Just see this and tell me what is the result of the following piece of code. Okay, public class person. We have a talk, and I am person, and this is the end of this class. And we have another class called student, extends from person, and it's printing I am student. I am student. Now, the basic behavior you have seen, like if I have to make an object, the way you make an object is like this, right? If I have to make the object of person, you see, you say person, P is equal to new person. So which object I am making, guys? Which object I am making here? Parent class or child class? If I'm doing person P is equal to new person, which object I am making here? We just about to conclude, 15 minutes more. But listen to this concept. Oh, screen is not sharing. Sorry, sorry. Thank you. Uh, person P is equal to new person. Okay, and let me also show you the code. I guess you haven't seen this. There's a class called person. There's a question I thought of asking before I go for the next concept. Public class person, and we have a method called talk where I'm saying I'm a person, and we have another class called student, extends from the person, so it's a child class. And overriding this method, you see the overriding rules are proper, and it's printing I'm a student. Okay, it's printing I'm a student. Now I'm making an object like this: p person P is equal to new person, and say p dot talk. Which method gets called, guys? Which method gets called when I say person P is equal to new person and P dot talk? If you are typing, I was not able to see. Manoj has replied person talk method, but which talk method, guys? Yeah, here is the code, Varshit. Talk method of parent class or child class? Parent class. Okay, very nice. Okay, parent class, because I'm making parent class object. And okay, now if I say child C is equal to new, sorry, student, right? So let's make it student S is equal to new student. Okay, student S is equal to new student. And I'll say S dot talk. S dot talk. Now tell me which method gets called now. Which method gets called now? Student class method. Correct? Student class method gets called. Nice, nice. But if I say, okay, like this, if I say person P is equal to new student. First of all, tell me, is it allowed? Because we never did this before, it looked like weird. Is it allowed, first of all? Person P is equal to new student. Okay, Sarla thinks it's allowed. How it is allowed, Sarla? And what object you're actually making? Everybody thinks it's allowed. Okay. Okay. Uh, okay, nice. So this is allowed only in inheritance. You all agree, first of all? If these are two different classes, then not allowed. All agree? This is allowed only in inheritance, because in inheritance, parent class can refer to child class object. In inheritance, parent class reference can refer to child class object. Parent class reference can refer to child class object. Okay, so I will tell you what is the advantage of this. Okay, what is an advantage of this? But first question here is, which object I am making? Person object or student object? Which object I am making in this line? At this line, which object I am making? Okay, and if I say P dot talk, P dot talk, now tell me which talk will get called now? Child, okay, parent. I'm getting mixed answers. Okay, so here, as I told you, like we are making a student object. Okay, we are making a student object, but person reference. Okay, parent reference, I can say. Parent reference, but student object. Student object. So when I say p dot talk, then it will print I am student. It will print I am student because it will be a student object. Okay, and why it is called runtime polymorphism, or this concept is also called as upcasting. We will see that going in detail. We will talk about it. Now let's see what will be the question. Okay, so that we can answer this question and we can proceed with the discussion of dynamic method dispatch and runtime polymorphism. We'll see. So now basically, if this is a question and if I write in this similar way as I told you, okay, if I write person P is equal to new student P dot talk, are you all clear that it will print you I am student, even though P is of type parent person, but it will print I am student. You all agree with this? Yes, Monica says yes. Come on, others, as a conclusion, you can please respond. You all clear? that it will print you I am student, not I am person. Okay, very nice. Okay, now let's see what is okay, anyhow. Okay, so let's see what is this runtime polymorphism. Okay, what is mean by dynamic binding or upcasting, late binding? A lot of questions can be there. Let's try to understand, and most importantly, what is the benefit of this? See, one thing is you will understand writing percent p is equal to new student is okay, but interviewer definitely will ask you why. What is the benefit of it? So let's try to understand so that we can conclude in a nice way. Because dog extends animal, Java understands that every dog is an animal, right? So when I write, as in our previous example, we were making animal and dog. So when I say animal A is equal to new dog, that's called runtime polymorphism, or we call it as dynamic binding or upcasting. This means that dog object can be treated as an animal. Okay, because they are parent and child. Dog is a child class for an animal. So a parent class can refer to the dog object. So, but remember, we are not making the animal object. We are making a dog object basically, but referred by the animal reference. Referred by the animal reference. So animal A is equal to new dog. So this concept is called runtime polymorphism, dynamic binding, or upcasting. Let's see what is the benefit of it. What is the benefit? So when I say animal A is equal to new dog, this line has two parts. Left side, animal A, which is a reference type. Right side, new dog, the object type, the actual object created in the memory. So with this line, we got a clarity that we are creating a dog object, but referred by the animal. We are creating a dog object referred by the animal here. Okay. Okay. Next is you're saying I'm creating a dog object but referred by the animal. This is called upcasting because converting a child class object into the parent class reference is animal. That is what we discuss in subtype, super type kind of thing. So this is basically called upcasting. We don't call it as widening and narrowing. Widening and narrowing happens in the primitive types, whereas in class types, we call it as upcasting and downcasting. That can only happen in inheritance case. Okay. If these two different classes, then it doesn't happen. Okay, upcasting and downcasting. So we'll be discussing what is downcasting as well. But first, let us try to understand what is upcasting because you get this question in Viva as well as in interviews. That what is upcasting? You can say converting a child class object into a parent class reference is called upcasting. So is the definition for upcasting clear for all? What is upcasting? Okay, thank you, Arun. Okay. Now, this is what happens, right? Upcasting dog will be upcasted to animal. So when you move from child class to parent class, you are moving up in the inheritance chain, and this term is called upcasting. It is automatic. No, explicitly you don't have to do because dog is an animal and it will do upcasting automatically. Same like widening. Same like widening. But now most important question is, we use upcasting to generic and flexible code that works with a different subclass. Let's see with why it is so powerful, why it is so important. Okay. Without inheritance or upcasting, it is look like this. Let's say we create dog D is equal to new dog. Then cat C is equal to new cat. We have to say D dot eat, D dot C dot eat, and goes on. So this is okay with two or three classes, right? If we have 1,000 classes, you have to make 1,000 objects. You agree with me? This is important. So last 5 minutes, I need all of your attention so that you can answer this in your Viva and interviews and you can justify. So if there are 1,000 objects, I mean 1,000 classes like dog, cat, lion, horse, cow, okay, you have to make all the objects. Okay, do you think that how the upcasting will help us now? Yes. If we use runtime polymorphism, we can create all of them with same reference. Very nice of you. How can we do that? This works, but what if we have 50 different animals? You have to make 50 different objects, right? You need 50 different variables and methods calls. You agree with this? You agree with this slide? Yes. Yeah. Meantime, Varshit, can you help us like how you can do that? With one reference, how can you make multiple objects? Let's say I wanted to make 50 objects. Is it possible with one reference, Varshit? Instead of having 50 variables, is it possible? Okay. Can you just show me with an example or can you help us with an example? How can I do that? Okay. To continue with worship, to help worship, let me show you how can we do what worship says that now you don't need 50 variables. You can create one reference and make 50 objects like this. Okay. You agree? I'm making an array of objects as animal. Now I can store new dog, new cat, new lion, new animal. All this I can store in the array. And now I can call with a for loop. I can call all of them. Even there are 50 objects, 1,000 objects, 10,000 objects. This code will work with only one reference. You agree with this? So this is the main benefit of upcasting or runtime polymorphism. Why we call it as runtime polymorphism or late binding? Because this will be decided at runtime to which it's pointing. First time in the for loop, you can say if I'm getting the dog object, so animal contain A contains the dog object, so it will call the dog method. Okay, dog eat method. Next time it will contain the object of cat, so it will call the cat method. Third time, if it is contained for lion, it will call the lion method. So that is why it's called runtime polymorphism or late binding or dynamic method dispatch, because it will be decided at runtime. It will be decided at runtime which method is getting called. So now can you justify what is the advantage of upcasting? This is one question you will get. Second question is what is dynamic method dispatch? What is late binding? Okay. And what is runtime polymorphism? Can you answer all of these questions with this example? I hope you are all noting out this example so that you can answer at least in Viva. For further, you need to refer and you need to elaborate so that you can justify in interviews. But if you can justify this in interviews, they will definitely accept. Now I wanted to wait here and see if we have any questions on the advantage of upcasting. Advantage of upcasting. Okay. This is how you, if any time you get the question, advantage of upcasting, you can show like, you can just take this example. Okay. And also you can explain this example for explaining what is runtime polymorphism, what is dynamic method dispatch, or what is late binding, because this is happening at runtime, not at compile time. So compiler doesn't know which each method is getting called unless at runtime it refers to the particular object. Object of a subclass as an object of its super. Very nice, Abhi. Clear for all. A quick confirmation because this slide is the most important slide, whatever we have discussed today. For interview purpose or for Viva, it's the most important slide.